Hi everybody. Today we have our final lecture in informatics, and today we will talk about some different topics. Today we will talk about formalizing clinical data and medical knowledge. I want to discuss a question about clinical coding system, and we will finish to discussing trends of computer innovations in healthcare. So basic questions we will cover in this lecture is introduction to classification, different classification basics, and medical classification system. And last part of our topic is we will discuss trends which shaping our future in medical care. So if we are talking about traditional patient care, data are available in written format only, mainly as free text, but sometimes also as numeric data, so as laboratory tests results. Reconstructing the patient history from such a handwritten patient's record by a clinician over than the original author is hindered by the fact that many medical terms are ill-defined and are perhaps even ambiguous. Medical coding is the process of assigning standardized medical codes, different types, medical, mnemonic, and so on, to patient medical charts. This coded information is used to ensure both the insurance companies, government organizations, patients alike all receive accurate billing statements for medical services performed. At this slide, you see background of classification because it is difficult to understand this handwriting. Because of this, we should use special electronic forms to fill up information into the computers and to get information from the computers also. And this is example of part of electronic medical records, and from the classification. Advantages of coding medical data shown at this slide. First of all, we will use data reduction. Then we will use standardized terminology, enable statisticians overviews and research, support of management and planning, and coupling with decision support systems. Classification basics submitted by classification definition, purpose and concepts, ordering principles, nomenclatures and thesauri, codes, taxonomy, and nosology. The term classifying has two different meanings: the process of designing and classification, and the next meaning, the coding or description of an object by using codes or terms that are designators of the concepts in a classification. We will use only the first meaning of classifying. A classification is an ordered system of concepts within a domain with implicit or explicit ordering principles. The classification is based on prior knowledge and forms a key to the extension of knowledge. The purpose of a classification is to support the generation of healthcare statistics or to facilitate research. Examples are the classification of abnormalities of electrocardiograms or diagnosis of patients into disease classes. At this page, you see example of ECG abnormalities in the athlete, which are subgrouped into common up to 80% and uncommon, less than 5%. And there are explanations of these two subgroups. Concepts are ordered according to the generic relations. Generic relations are relations of the type A is a kind of B. For example, pneumonia is a kind of lung disease where pneumonia represents the narrower concept and lung disease represents the broader concept. Classifications contain concepts within a certain domain. The domain can be defined as a set of elements to which a variable of function is limited. Any area of interest that might be modeled to create an information system. Examples of domains are a reason for encounter, diagnosis, and medical procedure. In this respect, the International Classification of Disease, 7th edition, ICD-9, is a classification of diagnosis. A classification allows one to compare findings collected in different environments. Classifying is done according to a single criterion. Age, that is, age is used as a differential criteria. In classifying diseases, we deal with the following aspects among others: anatomic location, etiology, morphology, and dysfunction. Each of these aspects can be used for a different ordering. Such an ordering through a classification is called an axis. Multi-axial classifications use several orderings simultaneously. In the International Classification of Primary Care, ICPS, for instance, the diagnoses are classified along two axes, one for the organ system and alphabetic character, and one for the components. ICPS has primarily been designed for epidemiological purposes. One of the problems of uniform registration in healthcare is the lack of common terminology. A thesaurus is a list of terms used for a certain application area or domain. Examples are the list of diagnostic terms or a list of terms for laboratory tests. For practical usage, for thesauri that also contain a list of synonyms, each preferred term have also been developed. One of the problems of uniform registration in healthcare is the lack of common terminology. A thesaurus is a list of terms used for certain application area or domain. Examples are a list of diagnostic terms or a list of terms for laboratory tests. For practical usage, thesauri that also contain a list of synonyms for each a preferred term, have also been developed. Restricted set of preferred terms used within an organization for a given purpose is called as controlled vocabulary. In a nomenclature, codes are assigned to medical concepts, and medical concepts can be combined according to specific rules to form more complex concepts. This leads to a large number of possible code combinations. The difference between a classification system and a nomenclature is that in the former possible codes are predefined, whereas in the later a user is free to combine codes for all aspects involved. The retrieval of records for patients, those data fulfill certain classification codes from a large database, is relatively easy. Retrieving records for patients stored by using a nomenclature is more difficult because of the high degree of freedom leading to very complex codes. So let's summarize this part. Terminology is a list of terms we use in the specific area. Thesaurus, ordered terms and synonyms for these terms. Classification, this is member of arrangement. Vocabulary, definition of terms we use in the specific area. Nomenclature, composition rules, and coding system is a system of codes as designators. Very difficult to use ordinary medical language in computer systems because of extremely complex vocabulary, terms often vague and imprecise, some disease known by several names or expressions. Synonyms. There are different synonyms for the same disease. A single term may have several meanings according to the context. Polysemy. Addressed by adopting format coding and classification systems. Different systems use same code or term in same way. Unique codes precisely define coding process. Benefits include abilities to share data between many systems, gather data about disease and treatments from many sources, deliver reminders, alerts, and other information to clinicians based on standardized clinical patterns or situations, identify eligible patients for requirement into clinical trials based on well-defined criteria, search professional literature based on standard queries, and many other benefits. Now let's talk about codes themselves. Coding is the process of assigning an individual object or case to a class or to a set of classes in the case of multi-axel classification. In most classifications, classes are designated by codes. Coding is, in fact, interpretation of the aspects of an object. For example, if we want to code gender, we can use one letter only. For male, for example, M, for female, F. This is a simple example of coding gender. Different types of codes are possible in classification systems. Number codes may be issued sequentially. This means that each new class will be given the next unused number. The advantage is that new classes can easily be added. Numbers could be issued at random to avoid any patient-specific information is hidden in the code. A series of numbers can be reserved for sets of classes. Issuing this type of number is only of use with a fixed set of classes, that is, then no expansion of the set of classes is expected. A mnemonic code is formed from one or more characteristics or more characters or its related class rubric. Advantages: this helps users to memorize codes. Disadvantages: for classifications with many classes, this may lead either no long codes or codes with no resemblance to the class rubrics used for limited lists of classes. Example: hospital departments are often indicated by a mnemonic code. For example, ENT, Department of Ear, Nose and Throat; CAR, Cardiology; OB/GYN, Department of Obstetrics and Gynecology. Hierarchical codes are formed by extending an existing code with one or more additional characters for each additional level of detail. A hierarchical code thus builds information on the level of detail of the related class and on the hierarchical relation with its parent class. This way of coding bears resemblance to the structure of hierarchical databases. This implies that patient data can be retrieved by using hierarchical codes at a certain level, even then significant extensions or modifications are made at lower levels. An example are the codes used in ICD-9 or ICD-10. Juxtaposition codes are composite codes consisting of segments. Each segment provides a characteristics of the associated class for each additional level of detail. At this slide, you see an explanation of, for example, of juxtaposition codes. Room with juxtaposition codes. The first letter application in ICPS, a diagnostic code is formed by using a code consisting of one letter of the alphabet, a mnemonic code followed by two-digit number. Example: all codes with the character D are related to the tractus digestivus, and all codes starting with N capital describe disorders of the nervous system. In the example of ICPS, two independent characteristics are coded simultaneously, and each characteristic has its own position in the code. The example of juxtaposition codes is the group number, student group number. It starts from the AL. This is faculty name, then first or second position, then you have group number, and next is the subgroup number. Example, at this slide you see example of the two Excel ICPS coding system. There is first column is the code, and second column is the organ system. First axis, this is organ systems, and second axis, components with numerical code which represent different components. To Excel ICPS. Medical procedures can be classified with ordering principles, action, equipment, aim, and anatomical site. The combination of 100 anatomical sites with 20 different actions, 10 different instruments, and 5 different purposes results in the classification system with a potential of 100,000 classes and codes. A way to cope with it is the use of combination code. By using a 6-digit combination code consisting of 4 segments, with segments dedicated to action 2 digits, equipment 2 digits, aim 1 digit, and anatomical site 1 digit, respectively, a coding clerk has to distinguish only 135 codes with which 100,000 combinations can be generated. At this slide, you see example of multi-level classification of medical procedures. The differentiating criteria are indicated between rectangles. The criteria for membership in each subclass are not adopted here. In value addition codes, in general, on the powers of 2 are used as representation of a data item or class. Several characteristics can be coded, but only one number instead of a segment for each characteristic is used as a code. Example, we code the presence or absence of risk factors such as 2 power 0 equals to 1 for smoker and 0 for non-smoker. 2 power 1 equals to 2 for overweight and 0 for no overweight patients. 2 power 2 equals to 4 for increased cholesterol and 0 for non-increased cholesterol. By using the codes 1 to 7, we can sum all the 3 risk factors mentioned above. Taxonomy is a theoretical study of classification, including its basic principles, procedures, and rules. Taxonomy is concerned with classifications in general. The term classification is used for the end product of the design process. Proposed cognitive taxonomy of medical errors. All the medical errors, all the human errors are divided into 2 categories, slips and mistakes. There are 2 types of each errors: execution slips and evaluation slips, and the same for mistakes: execution mistakes and evaluation mistakes. Then in the execution slips, we can discern goal slips, intention slips, action specification slips, action execution slips. For evaluation slips, perception slips, interpretation slips, and evaluation slips. Mistakes are divided into goal mistakes, intention mistakes, action specification mistakes, and action execution mistakes, evaluation mistakes, perception mistakes, interpretation mistakes, and evaluation mistakes. Nosology is usually defined as the science of the classification of diseases. Nosology is usually distinguished from nosography, which is the science of the description of diseases. Difference between the definition and the description of disease. A disease definition gives only essential characteristics of the disease. Whereas a description includes accidental characteristics. Now let's talk about some medical classification system. There are a lot of medical classification system. At this slide you see some examples. The most popular is the ICD, International Classification of Diseases. Different variants, different versions of this classification of diseases are possible. ICPS, International Classification of Primary Care, SNOMED, Standard Nomenclature for Medicine, DRG, Diagnosis Related Groups, ATS, Anatomic Therapeutic Chemical Code, LOINC, Observation Identifiers, Names and Codes, MESH, Medical Subject Headings, and there are different specialized coding systems such as National Cancer Institute or Center for Disease Control. ICD, the International Classification of Diseases, has been used since 1833 to classify diseases and other health problems recorded on many types of records, including death certificates and health reports. In addition to enabling the storage and retrieval of diagnostic information for clinical, epidemiological, and quality purposes, ICD also provides a basis for the compilation of national mortality and morbidity statistics by WHO member state. ICD, International Classification of Diseases, is the archetypal coding system for patient record abstraction. The first edition was published in 1900 and it is being revised at approximately 10-year intervals. The most recent version is ICD-10. At this slide you see part or piece of International Classification of Diseases. All diseases are grouped into some categories, such as in this. You see these subcategories at this slide. ICD-10 consists of the core classification for 3-digit codes, which are the minimum requirement for reporting mortality statistics to WHO. An optional 4th digit provides an additional level of detail. At all levels, the numbers 0 to 7 are used to further detail, whereas the number 8 is reserved for all other cases and the number 9 is reserved for unspecified coding. Uses an alphanumeric code that indicates the location of the concept within a disease hierarchy. For example, A93 is the lupus erythematosus. Exclude extends A18.4. Use additional external cause code if drug induced. L93.0 discoid lupus erythematosus, and for example L93.1, this is subacute cutaneous lupus erythematosus. Example of a 4-digit code level in ICD you see at this slide. Next step of classification is diagnosis-related groups. Diagnosis-related groups developed for relating the type of patients a hospital treats, case mix to treatment costs. All discharged patients classified into a diagnosis-related groups, a limited clinically coherent set of patients classes based on age, sex, principal diagnosis, secondary diagnosis, surgical procedures, and discharge status. All patients are unique, but groups of patients have common demographic, diagnostic, and therapeutic attributes that determine resource needs. This slide shows the part piece of DRG classification. SNOMED, this is system. The translation is the systemized nomenclature of medicine. The primary purpose of SNOMED is to encode the meanings that are used in health information and to support the effective clinical recording of data with the aim of improving patient care. Intended to be a general purpose, comprehensive and computer interpretable terminology to represent and index virtually all the events found in the medical record. At this slide, you see the example of SNOMED code for tuberculosis. The first letter D, this is disease or diagnosis. Letter E means infections of parasitic diseases. Then first number is bacterial infections, and then the last number is tuberculosis. X reference concerns living organism, morphology, and function. There are many overlapping classifications, not only for the coding of diagnosis, but also for the classification of medical events. Also, most diagnostic coding systems try to be compatible with the ICD family. ICD itself represents only a limited view, and it's unable to fulfill the needs of all users. Systems such as SNOMED have much more expressive power than the more rigid systems such as ICD-9 or ICD-10. Wide acceptance of a coding system is essential for the development of decision support systems. International institutions such as WHO, with the recognized collaborating centers, play an important role in the standardization process. This is only overview of different classification systems. Now let's talk about trends in computer innovations and healthcare. We will identify the trends that will have the greatest impact on future, and we try to identify the technologies that will have the greatest impact on healthcare. Trends shaping our future are shown in this slide. World's population will double each 40 years. Population in developed countries is living longer. Growth in information industries creates a knowledge-dependent global society. The global economy is becoming more integrated. The economy and society are dominated by technology. Pace of technological innovations is increasing, and time is becoming one of the most precious commodities. Then disruptive technological innovations are transforming the world around us in unpredictable ways. A new era of digital consumerism is radically changing the way customers shop for products and services, which is impacting the business consumer ecosystem. A digital consumer does not differentiate between these trends. For a customer, these trends are just an extension of his experience with the modern around him, be it interacting with a retailer or a bank or hospital. All these trends need to work together to deliver an outstanding customer experience. Just focusing on the technology in isolation of the other will not work. The following techniques have the potential of change our future. Look at these technologies: big data, cloud computing, social media, mobility, embedded systems, and augmented reality. Let's discuss each of these trends. Big data. Every year, companies and individuals generate billions of gigabytes of data and terabytes of data. Data which properly analyzed and used in time can emerge as unbeatable competitive advantages. Enterprises need to recognize the prospect big data represents and should adopt their IT strategy to capture such opportunities. Big data can help retailers predict buying decisions of shoppers. It can help banks weed out fraudulent transactions, while government can use big data to provide services directly to their citizens. The next trend is the cloud computers. The undeniable power of cloud computer to foster innovations and improve productivity is now accepted by both IT vendors and their customers, while the financial services and government sectors are mostly moving to a private cloud model due to information security concerns. Other industries like healthcare have adopted basic cloud. Social media strategy has become a must for all enterprises, be it bank, retailers, or the government, with over 1 billion individuals logged into various social network. People are now using social media for advice and what products to buy, where to shop, and even regarding what films they want to work with on how to treat themselves. Mobility. Mobile devices have changed the way people access digital content. Smartphones and tablets have brought rich digital content to the fingertips of customers. Next trend is embedded systems. The decreasing cost of embedded systems has moved their presence across the business landscape. Embedded systems like RFID chips have revolutionized supply chains to retailers. Embedded systems are also having an impact in the healthcare industry. The hospitals attach smart chips to patients to keep track of their entire medical regime. Augmented reality. Over the past some years, augmented reality has moved from the world of science fiction to our everyday lives. The spread of smartphones and tablets have risen to the spread of location-based augmented reality applications, and now everyone from retailers to healthcare providers have embraced augmented reality. Augmented reality exchanges the customer experience and enables enterprises to add a fourth dimension to their products. The healthcare sector stands at the inflection point and is witnessing a transformation due to the government regulations and initiatives to bring down the healthcare costs. IT is getting interwoven in the industry of the form of electronic medical records, electronic health records, clinical trial management system, clinical decision support systems, data mining systems, hospital information systems, electronic prescribing systems, ambulatory care management system, patients management system, computerized physician order and entry system, and not clinical systems, to name a few. Consumers are increasingly using web, connected devices, and innovative health information technologies for self-monitoring, facilitate interactions and information exchange with doctors, and support treatment adherence. There are 6 trends that could shape our future. While technologies such as big data and cloud have been dominating the imagination of enterprises for the past couple of years, new disruptive trends like augmented reality and social media have now started having a tangible presence. As per their studies, leading analysis firms have estimated that the maturity curve of this technology is to increase at a rapid pace over the next decade, with big data and cloud estimated to reach a market potential of tens of billions of dollars. Healthcare services refer to provision of consultation, diagnostic, patient care, and medication services to a patient suffering from injury, illness, diseases. The global healthcare market is well poised for growth, with per capita healthcare expenditure growing in most countries due to changing lifestyle, aging population, and availability of better healthcare infrastructure. These countries were either significantly underserved and are now witnessing capacity expansion or are actively upgrading their healthcare systems. Information technology is playing a critical role in changing the face and fate of the modern healthcare sector. Technology trends such as mobility, cloud, augmented reality, social media are making significant strides and are propelling the sector for incremental growth. Let's look at the key drivers of growth in the healthcare industry. First of all, it's changing lifestyle, aging population, and better availability of healthcare facilities is giving the healthcare market. Rising penetration of health insurance is leading to increased spending of healthcare services. Increased availability of doctors, medical services, and health portal is leading to an increased adoption, especially in the developing economies. Increasing awareness of health-related issues is also leading to expensive usage of healthcare services. So big data is the trend, the first trend. While the healthcare sector is poised for growth, at the same time, it is plagued with challenges. The primitive state of healthcare, especially in developing countries, can still be associated with paper prescription and manual health records. This brings in a challenge of managing large amount of unstructured data coming from their sources. In more developed economies, because of the emergence of electronic health records and patient care devices, patient data is getting digitalized, leading to data deluge. The healthcare sector is now witness the increased adoption of cloud computing, offering benefits such as lowered costs and reduced clerical effort of maintaining data. Cloud computing makes it possible for healthcare organizations to access and retrieve information stored in scattered system in a real time. Therefore, solutions such as electronic medical records, telemedicine, patient management, and medical imaging are gradually shifting to cloud. These cloud services can now also be integrated with special medical hardware embedded systems for remote patient monitoring. Healthcare Magic uh, is a healthcare portal which helps patients find doctors by specialty in India. The portal provides information on diseases and conditions and facilitates online uh, communication between patients and doctors. It gets funding from sponsorship and advertisement and also sells different membership plans to patients to interaction with doctors. Social media tools are gaining popularity, serving as an easy and cost-effective solution for both healthcare providers and patients. The internet, which has once a source of one-way communication only, has transformed into one that facilitates two-way interaction and information sharing. Healthcare providers can now monitor their patients in a vital environment, thus giving impetus to remove patient care and monitoring. It transforms the patient-doctor communication from one to one-to-many. The doctors reach out at a number of online users using the internet. Increasing integration of mobility with healthcare is giving rise to mobile health. From a physician perspective, a physician no longer has to rely solely in bedside terminal to retrieve patient health or medical information, while from a patient's perspective, a patient can seek medical advice more often and have flexibility in terms of point of care. Mobile health can be useful in serving a variety of purposes, ranging from the results viewing to ordering to electronic prescribing to reference data access and to remote monitoring. Mobility can play an instrumental role in efficient patient management and quicker handling of emergency situations, which in turn can save treatment costs and early care. Embedded systems and M2M technology have made automated medical devices that focus on disease prevention and healthy living a reality. As a result, doctor and hospital visits have also reduced significantly. Applications in the field of remote monitoring and telehealth being used for early detection and health warning are changing the face of healthcare sector. In the field of academics, augmented reality can be used by medical students to practice surgery in a controlled environment with 3D imagery and interactive display. Complex medical conditions can be explained to patients using visualization aids. It can also provide improved sensory perception to the surgeon and reduce the risk of an operation. It can also be combined with MRI or X-ray systems and bring everything into a single view for the surgeon. So let's summarize our course. We finish our course for today. We finish all the 8 lectures. And the main from our course is that computers are an essential part of healthcare and also a necessity. All healthcare services have gained a greater ability to treat, diagnose, and care for patients through computerization. Every healthcare worker should have basic computer literacy. And the bottom line, computers do enhance the quality of patient care. Thank you for attention. I think you'll be good doctors and you will use computers and computer technology in your future life.